Here's an example of a simple quadratic equation. X squared is equal to 25. It's quadratic because of this x squared term. We're going to solve this just by thinking about it. What number squared is equal to 25? Well, 5 squared is equal to 25, so x equal 5 is a solution. Minus 5 squared is also equal to 25. Minus 5 times minus 5 is equal to positive 25, so x can also be equal to negative 5. So this quadratic equation has two solutions, and we'll see that's usually the case. Usually quadratic equations have two solutions. Let's look at another example. All right, here's another quadratic equation. 2x squared plus 3 is equal to 21. Now we'll try to solve this by using basic operations, such as adding the same number to both sides or dividing both sides of the equation by the same number to solve for x squared. All right, so we're going to solve for x squared. We're going to subtract 3 from both sides. And we have 2x squared is equal to 18 and divide by 2 both sides. Okay, I'll continue up here. We have x squared is equal to 9. So what number squared is equal to 9? Well, 3, or minus 3 times minus 3 is also 9. So we have two solutions, 3 and minus 3. Okay, now let's look at this third example. X squared minus x is equal to 0. And let's see, if we try to solve for x squared, add x to both sides, we would end up with something like this. It doesn't get us anywhere. We're not solving for x squared because of this x term. You see, in this example, we didn't have an x term. We only had an x squared term, so we could solve for x squared. But usually that's not the case. Usually a quadratic equation will have an x squared term and it'll have an x term. And so we won't be able to solve using basic operations like we did in the previous example. So we have to think of something else. So before we solve that previous example, x squared minus x equals 0, let's look at this equation over here, xy equals 0. So here we have two numbers whose product is 0. So let's just think of some possible values for x and y. Well, maybe x is equal to 5 and y is equal to 0. Or maybe x is equal to 10 and y is equal to 0. Or maybe x is equal to 0 and y is equal to 3. So these are pairs of numbers whose product is 0. Now, you might realize that we always have one of the numbers equals to 0. So we can say as a general rule, if the product of two numbers is 0, then one of them must be 0. All right? Sometimes we call that the zero product rule. All right, if xy equal 0, then x is 0 or y is 0. So this is called the zero product rule. Okay, now we'll go back to our example that we couldn't solve by simple means. All right, we tried to solve using basic operations and we didn't get anywhere. So let's factor the left-hand side. We could pull out an x. And we end up with a product that's equal to 0. So we know from our zero product rule that either the first factor is 0 or the second factor is 0. The first factor is x and the second factor is x minus 1. So let's write that down. X is equal to 0 or x minus 1 is equal to 0. X minus 1 equal to 0, well, just add 1 to both sides. It's the same as saying x equal 1. So these are our two solutions of our quadratic. We just solved it using the zero product rule. The two solutions are 0 and 1. You see, if we substitute in 0 here, we get 0 minus 0, which is 0. Or if we substitute in 1, we get 1 squared, which is 1. 1 squared minus 1, which is also 0. 1 minus 1 is 0. So we see that by check, we can quickly check that both solutions work, or both are correct. Now let's apply this zero product rule to other examples. This is called solving a quadratic equation by factoring. It involves the following 3 steps. First, you put your quadratic equation in standard form. Most important thing is that we want 0 on the right-hand side in order to use our zero product rule. Then we factor. Then we set each factor equal to 0 and solve. We're going to practice 3 different types of factoring examples, factoring quadratic examples, before we apply the factoring method to solving equations. So first let's factor this expression, and this one is factored by pulling out a common factor of 3x. So let's do that. And here we have 3. When we pull out 3x from 3x squared, we're left with, when we pull out 3x from 3x squared, we're left with x. And when we pull out 3x from 12x, we're left with 4. So we factored the first example by pulling out a common factor, pulling out the greatest common factor. The second example we can factor as a difference of 2 squares. And this third example requires reverse FOIL. So let's do that. We'll fill in here with 2x, x, and because c is negative, the signs are going to be different. All right, we can only fill in with 1 times 1. That's the only choice. And for factors of 1, check the middle term, and we have x minus 2x, which leaves us with negative x. Middle term, but wrong sign, so switch these. All right, so that was the third method of factoring quadratics, which is reverse FOIL. Okay, here we have a quadratic equation. It's already in standard form. It's already equal to 0, so we'll go straight to the second step, which is factoring. We can factor out 4x. We're using the greatest common factor method here. Pull out 4x from the first term, and we're left with x in parentheses, and pull out 4x from the second term, and we're left with 2. So now we want to set each factor equal to 0 and solve. Okay, here just divide both sides by 4, and we have x equals 0. 0 over 4 is 0. So that's one solution. And here solve for x, and we get x is equal to negative 2. So those are our 2 solutions, 0 and negative 2. Number 5 is a difference of 2 squares, so we'll factor as a difference of 2 squares. Okay, remember the following: a squared minus b squared is equal to a plus b times a minus b. So here we have x squared minus 7 squares, so this factors as x plus 7, x minus 7. And set each factor equal to 0 and solve. Subtract 7 from both sides. X equals 7 is one solution. Add 7 to both sides. Sorry, this one's x equal negative 7, and this one is x is equal to positive 7. So 2 solutions, negative 7 and positive 7. In number 6, we're going to factor using reverse FOIL. Okay, first times first will be 2x times x. This is c is negative, so signs are different. We'll try 7 times 3. We want to get 11x in the middle, so I'm going to put the 7 here and the 3 here. Check the middle term. Okay, so here we have 3x minus 14x. The sum is negative 11x. The middle term has the wrong sign. So we're just going to switch the signs, and we have 2x minus 3 equals 0. So now we're up to the step where we set each factor equal to 0 and solve. Add 3, 2x is equal to 3, and divide by 2, and we have x is equal to 3/2. So that's one solution. Here subtract 7, and we have x is equal to -7. Okay, so those are our two solutions. Now in number 7, we notice that we could divide both sides by 5, so we'll start by doing that, all right, and then we'll get 0 on the right hand side. We don't have 0 on the right hand side, but let's start by simplifying. Divide both sides by 5, and we have x squared is equal to 4. All right, now we're up to step 1 really, which is put this in standard form. We need a 0 here. We need 0 on right hand side. So just subtract 4 from both sides. All right, so we have x squared minus 4 is equal to 0. And we know this is a difference of two squares, x squared minus 2 squared. So factor as a difference of two squares. And now we're up to setting each factor equal to 0 and solving. And those are our two solutions, x equal -2 and x equal 2. Right, in number 8, step 1 is we need 0 right there. So we're going to subtract that 22 from both sides. I'm just going to squeeze it in right here. So we have, sorry, this should be a 3x squared here. So that's 3x squared plus 31x minus 22 is equal to 0. All right, so this is standard form. Now we're up to step 2, factoring. Fill in with a 3x and an x, different signs. And we're going to go with 11 times 2 for the factorization of 22, 11 times 2. Now I want to get a 31 in the middle. That's pretty big, so I'll put the 11 here, so I'm up to 33. All right, let's check the middle term, 2x. And here we have minus 33. We get, minus 33x. For middle term, we have minus 31x. And we have a positive 31x. So same middle term except for the sign. When that's the case, if you have the same thing except for the sign, just switch. All right, so we're setting 3x minus 2 equal to 0 and x plus 11 equal to 0 and solving. Add 2 to both sides. Divide by 3. Here, subtract 11 from both sides. So those are our solutions, 2/3 and -11. Number 9 is already in standard form. We have that 0 on the right-hand side. Here we can just factor out the greatest common factor of 3x. So let's do that. We're left with x minus 2. And set each factor equal to 0 and solve. Here, divide by 3, we get x equals 0. Add 2, we have x equal 2. Two solutions. Okay, number 10, this is not in standard form. We need 0 on the right-hand side, so we're going to subtract x from both sides. Now we're going to put the x in the middle there because we want it in standard form. We want the x squared first, minus x second, and then minus 10 equal 0. So now the quadratic equation is in standard form. So we're going to factor. Okay, let's put in our 3x and our x. Again, we need different signs here because of the minus 10. Okay, so we'll do that. And let's see, here we'll fill in with, let's try 5 times 2. All right, so either 5, 2 or 2, 5 we're going to try. All right, we want the middle term of minus 1, the coefficient of minus 1. If I put the 5 here, I think it's going to get too big. We're going to get a 15, so I'm going to put the 5 here and the 1 here. Sorry, 5 times 2, 5 here and the 2 here. Okay, let's check this middle term, 5x minus 6x minus x. Okay, that's the correct middle term, so we just leave it and set to 0 and solve. So here we have 3x is equal to negative 5, x is equal to minus 5 over 3, and here we have add 2 to both sides, x is equal to 2. So those are our two solutions, 2 and minus 5/3.